Hi, we are Group 9. We will present our assignment today, and before that, I will introduce my group mate.
Okay, for data arrangement, we have class interval and frequency. For 20 to 44, we get the answer of frequency. Then E, we have 8. Okay. For class interval number 2, 44 to 69, we have 13. 17 to 94, we have 11. 90 for 119, we have 9. 120 to 144, we have 4 frequency. And last, 145 to 169, we have 5 frequency. Okay, next. So it is same, which is the above information. Okay, from the relative frequency, 8 divided 50, we get 0.60. 13 divided 50, we get 0.26. Okay, next. 11 divided 50, we get 0.22. Okay, next. 9 divided 50, the answer is 0.18. 4 divided 50, the answer is 0.8. And the last one, for graphical method, we choose frequency polygon. A frequency polygon is a graph considered by using a line to join to the midpoints of its interval. The midpoints of the interval from a frequency distribution table can be used to construct a frequency polygon. The interval midpoint is determined by the combine the upper and the lower boundaries and dividing by 2. Below shows the table and graph of frequency polygon. So this is our schedule and our graph. For graphical method number 2, we choose algebraic graph, which is algebraic graph is a type of the graph that shows the cumulative frequency and each class is the upper boundaries. Table 2 shows the dataset of n above n. Graph 2 represents an algebraic graph. So we have class, upper boundaries, frequency, and cumulative frequency. So this is our schedule and our algebraic graph.
Hello, welcome back with me. I'm Nikon Rafael. I will present in this part which is measure of center tendency. Center tendency are objective summary of data through a single value that affects the center of data distributions. A measure of center tendency is a value that represents the center of distributions. There are most commonly used a measure of tendency for ungrouped and grouped data, means, medians, and mode. Here we can see the table of our data. There is frequency. We have class interval, main point, frequency, and FS. So the total of frequency is 50, while the second column is 2863. And we can see the below of the table. We can see how we count how we count the all total in this table. So the next part is measure of positions. Measure of position is give us a way to see where is a certain data point or value falls in the sample distributions. A measure can tell whether a value about the average or whether the answer usually high or low. Measure of position are used quantitative data that fall on some numerical scales. So here we have a 3 column of table. Here we have class intervals, frequency, and cumulative frequency. So in this part we have to count four steps, which is we find the location of quantile, and we use the following formula to determine the QI, Q1, and Q3, like you see in our slides and our report. So the first is we count a location of QA. So the answer we get is 13.5. So location QI is a 13.5. By preparing the location of QI on the cumulative frequency column, therefore class interval is 55 to 69, and then we count the formula determine. So we get the answer is 50. So therefore its Q is 50. And the next is we find the location of Q3. So in the Q3 we get the answer 27.5. So location for Q3 is 37.5. By preparing the location Q3 on the cumulative frequency column, therefore class interval is 59 to 119. So we calculate the second answer following by formula determine. Is we get the answer is 102.2. So therefore Q3 the answer is 102.2. So the last but not least, there is measure of variations. Like you can see in our slide, there is our timetable, which is we find the other answer. So if after we get the answer, we can find the variance and standard deviation steps. So after we count, we get the sample variance is 1970, and the sample standard deviation is 44.38 only. So now we is on the last part of my part, which is the shape of distributions. This shape distribution is described by its number of peaks and by the position of symmetry, its tendency to skew or its uniformity. The Tribousi shape quantitative data can be described as the logical order to the value, and the low and height and value on the x-axis and histogram are able to identify using a measure of central tendency. So like we see in our slides, this all the answer that we combine in this shape of distributions. So interquality range, quality 3 Q3 and quality 5 Q1s. So we get 50 minus 102.2. So the calculation answer is 52.2. And the shape of data distribution is the mean is 77.6, median is 11, mode is 468.9, and we can see the mean is bigger than median, and median is small from mode. So therefore, it's like a weak to the left. Thank you from me. See you again.
Represent the number of score that student get before studying for the exam, and Y represent the number of score that student get after studying for the exam. So the score before and after the study are likely to represent quantitative data as they involve numerical measurement. Quantitative data provide a basic for statistical analysis, allowing a researcher to apply statistical tests to explore pattern, trend, and also relationship. The use of quantitative data facilitates the application for correlation coefficient or regression analyzed to examine the association between the two variables. The next part is calculation for the R value. So this is the calculation for the R value, which is the final answer are 0.00077188275. Lastly, interpretation of value R. The value R, which is 0.00771888275, present the correlation coefficient between two variables, which is the score before study and the score after the study. So in this case, a correlation coefficient close to 0 indicate a very weak or negligible linear relationship between the score before and after the study.
Calculation and equation. For B1, here is the formula and calculation. The answer is B1 0.811. For B0, the answer is 1.922. Why? 1.922 plus 0.811x. Therefore, the simple linear regression equation is the score after study 1.922 plus 0.811, the score before study. Interpretation of regression coefficient. The rate at which one variable changes in response to change in another is represented by the regression coefficient, which is a constant. B0 to 1.922. When score before study x is 0, the score after study y equal to 1.922. Next, B1 0.811. Each unit increase in score before study, the score after study is expected to increase by 0.811.